Okay, let's start our trig unit here. It's going to be a little bit chopped up, but it'll be okay. Starting off with some definitions and some review things. First of all, the definition: an angle is the union of two rays with a common endpoint. I know, geometry's back again. I gotcha. And a protractor is an instrument used to measure an angle. And just in case you forgot what one looks like, there's what a protractor looks like. Remember, you read from the here you would read the inside numbers. From over here you'd read the outside numbers. Okay. Some new things we need to talk about are the initial ray and the terminal ray. So initial ray is where the angle begins, where we start to measure. So if we're going to measure this angle, we would put this baseline. First of all, we put our vertex right there, and we put our baseline on that line. And then we would extend this out and we would measure the angle. Okay, same thing over here. We would put the baseline down here on the green line, and we would measure here. Okay, and again, we're on the inside because we would start at 0. Over here, I'm showing you that. I again have the baseline on, and we're going around. So, just a quick review on how to measure an angle. Okay, well, in geometry, we were taught that an angle measure had to be between 0 and 180 degrees. Well, not always true, and here's why. We now can have measures of angles that are both positive and negative. A positive angle measure, if they're measured counterclockwise from initial to terminal ray. So if we measure them going this way, this is considered a positive angle. If we measure going this way, it's considered a negative measure. Again, if I'm going up, it's positive. If I go down first, it's negative. Okay, if I go up, it's positive. If I go down, it's negative. So we have both negative and positive angles. The symbol that we use to mark things like that in geometry or in trigonometry is the theta symbol. And I usually write it like this, just so you know, it's like a big O. Probably not perfect, but it'll work, and they get really sloppy, so don't worry. Okay, but here's the key to today. Standard position. An angle with the vertex at the origin, an initial ray on the positive x-axis, the terminal ray will fall in one of the 4 quadrants, or on one of the axes. And we're gonna define all of that before we're done. So notice how I always have the green line off to the right, my vertex is in the center, and my red can go anywhere. It can go either direction, it can go either way, it doesn't really matter. So positive measures if I measure this way, and negative measure if I measure this way. Okay, so far so good. So here's where it gets a little crazy. We have a special group of angles that are called quadrantal angles, and they're called that because they're angles in standard position where the terminal side or the terminal ray lands on one of the axes. So it's a little bit different than a regular one. So in this case, if my initial ray is here and my terminal ray is here, I would say this is in the negative x position. If it's over here and down here, this would be the negative y. This would be the positive x because they're landing on top of each other. And this would be positive y because this is the positive part of the y-axis, just like this is the negative part of the x, the negative part of the y, and the positive part of the x. So quadrantal angles have those specific attachments to them. Okay. Oops, I'm trying to do 2 things at once here. Oops, it did. Go back. Okay, so now let's talk about those quadrants. First of all, notice that they are numbered from the upper right corner to the upper left corner to the lower left corner to the lower right corner. Okay, I guarantee you need to know that. Also, notice that they're all in Roman numerals, and that is the way they would prefer. That is how mathematicians label them. Labels 1, 2, 3, and 4. Okay, notice quadrant 1 is only angles from 0 to 90 degrees. Quadrant 2 goes from 90 to 180. Quadrant 3 goes from 180 to 270, and quadrant 4 goes from 270 to 360. So each of them contains 90 degrees, but notice there are no equal signs. We just defined all of those. If it lands on this line, it's the positive y. If it lands on this line, it's the negative x. If it lands on this line, it's the negative y. And if it lands over here, it's the positive x. So that's why there are no equal signs over here. So the question is, how do I draw a 200-degree angle? Notice it's positive, so that means I'm going to start with my initial ray over here. And now I'm going to draw my terminal ray at 200 degrees. Well, let's see. That's 90 degrees to quadrant 1. That's 180 degrees to get through quadrant 2. And 20 degrees past that, there's my 200-degree angle. Okay, again, 90, 180, so 200 must be down here. How about 74 degrees? Again, it's a positive number, so, and it's in quadrant 1, and I know it's in quadrant 1 because it's between 0 and 90. So 74 degrees, it's about right there. We'll call it that. And here's my initial and my terminal ray. How about 500 degrees? Well, let's think about that a minute. Can I do 500 degrees? I sure can. Let's think about this. Okay, so here's what I'm going to do. Here's my initial ray. Got it. Now my terminal ray. In order to get my terminal ray, I have to go all the way around. That's 360. So 500 minus 360 leaves me 140. So beyond that, there's another 90. And there's a 50, so there's 340 or 140 degrees past 360. Notice the curlicue. That is how we represent a 500-degree angle. I went all the way around and an additional 140 degrees. So far, so good. Notice the arrow tells me which way I went. Okay, negative 220 degrees. Okay, I'm going to start in the same place. I'm going to start there, but instead of going up this time, I'm going to go down. So I'm going to go this way. There's 90 degrees. There's 180 degrees. I need 40 more, so there's my 220. Notice my arrow. Here's my negative 220 degrees. Not so horrible. All right, let's see what's on the next page. All right, coterminal angles are angles in standard position whose terminal sides coincide. So here's a 45-degree angle. Let me do this really fast. 45. I'm not going to do all of these. Okay, there's 45 degrees. Here is a coterminal angle. I could go from this initial ray all the way around to there. Now my terminal side is in the same place, but now I've gone 405 degrees. That's one option. I could go this way around, and now I'm at negative 315 degrees, because 360 minus 45 is 315 if I go the other direction. Okay, let's try another one. How about coterminal with 195? Well, first of all, let's find 195. So here's my angle. 195 is going to put me about right there. Okay, just it's approximate. Okay, I could go this way. So 360 minus 195. Oh, let's do a little borrowing here. 5, that's a 5, that's a 6, 165. Yeah, that's about right. It's less than 180. So here's negative 165 degrees. I could also spin around. I could go this way, all the way around. And now I have 360 plus 195, which would be 555. Okay, an example of that. Okay, so it's not difficult to find them. How about 700 degrees? Let's find out where that is first of all. Okay, so initial, There's 360, so 700 minus 360 leaves me 340. So I went 360, I need to go another 340, so here is 700 degrees. Okay, a real quick one would be, oh wait, can I just do this? Yeah, how far from here am I? I'm 20 degrees away, so this would be 340 degrees. So 700 and 340 are coterminal. Now, I could also go this way, and that would be negative 20 degrees, because I went down first. Okay, not too terrible. Okay, well, now I'm going to burst your bubble. There are actually two measures of angles commonly used in math, and that's why your calculator is very important that I always check your calculator to make sure you're in the right settings. One, because there's a degree measure, and then there's what's called radian measure. Okay, radians are what we're going to work on right now. Okay, so to get you started, take a look at the picture. It has a radius, and I'm going to use this piece of wire I found here, see if I can do this. Okay, oh, it's way too long. Let's see if I can make it shorter. All right, this is going to be close. My question is, if this is the radius of my circle, how many radiuses is it going to take to get all the way around my circle? Oops, still, okay, it's about this long. That's my piece, right there. Okay, so how many of these do you think it's going to take to get around my circle? Well, I'm going to curve it a little bit, and I'm going to try to hold it on there for you. There's one. Okay, let me see if I can do this. There's one. There's two. Oh, look at that. There's three, and I'm not even all the way halfway around yet. There's four. There's five. There's six, and a little bit more. It's a little rough, but yeah. It's not seven, I promise you. But it's a common number that you, if you think about it, think about circumference, and that should give you a clue. Okay, well, I'll tell you what. It's 2 pi, or 6.28 radiuses. Okay, and that's why we call it 2 pi radians. Okay, so that's where the radians comes from. Okay, so that's right, 2 pi. That means there are 2 pi radians in one circle. It doesn't matter what size the circle is, it's always going to be the same. If we were in class, I would be walking you through that, showing you how that all works together. But we're not, so we're going to do it this way. Okay, a central angle of a circle, geometry, is an angle whose vertex is at the origin and whose sides are radii of the circle. So definition, when the central angle intercepts an arc that has the same length as the radius of the circle, the measure of the angle is 1 radian. 1 radian. Let's take a look at what that means. All right, here it is. So here we have a central angle. Here we have a central angle right here. Okay, notice definition. Here's a radius and here's a radius. And what it says is when this is equal to this is 1 radian. So when this is equal to the angle mark, let's see, that's about, let's see if I can do this. About that far, maybe about right there. So this has the same length as that, then this is 1 radian. And then you just use RAD. Okay, RAD for radian. All right, so let's talk about graphing in radians. Let me get my notes here. Hang on one sec. The right page here. Okay, so we want to graph some things in radians, but let's lay out the circle for us first. Like we did with the angles, we said, you know, if we're in quadrant 1, we're from 0 to 90 degrees. And if we're in quadrant 2, we go from 90 to 180 degrees. Well, there's a similar thing for this, and it works like this. As I go around the circle, since this is 2 pi, halfway around the circle would be pi. Halfway from 0 to pi is pi over 2, and halfway from pi to 2 pi is 3 pi over 2. So my posts are pi over 2, pi, 3 pi over 2, 2 pi, which we also call 0, depending on which way we're at, which direction we're going. So if we think in terms of fractions, if I want to graph 5 pi over 6, think about that a minute and ask yourself these questions. Is it more or less than 0? Well, it's more. Is it more or less than 1/2? Well, it's more. Is it more or less than 1? It's not quite 1. 5 divided by 6 is close, but not quite. So it would be over here in quadrant 2. Make sense? What if I wanted to graph, let's do 7 pi over 4. Okay? That's 1 3/4, right? 1 3/4 pi. So I already know it's past 1. Is it past 1/2? Oh, it is. 1 3/4 takes me all the way around to here. Here is 7 pi over 4. Again, think fractions. Think fractions. What if I want to do pi over 3? Okay, stop and think about it a minute. Is it more or less than 1/2? Oh, 1/3 is smaller than 1/2. So I'm over here somewhere, so I'm going to go about right there. If that's 1/2, then 1/3 is a little bit less. So here's pi over 3. Okay, what if I wanted to do 3 pi over 4? Think of it as 3/4. Well, 3/4 is 3/4 of the way to 1, and if 1 is over here, then this must be 3/4. Okay, and that's how it works. So this is how we draw angles. Think in terms of fractions. It'll be okay. You'll be fine. Okay, so far so good. Okay, so now let's look at some math. If it takes 2 pi radians to go all the way around the circle, or 360 degrees, then 180 degrees would be pi radians. Wait a minute, let's do that again. If 2 pi is 360, divide both sides by 2, I get pi equals 180. That makes sense. Using this knowledge, we have 2 simple ratios to remember. Okay, if I want to go from degrees to radians, I take the angle, so take the angle and I multiply it by pi over 180. Okay, if I want to go from radians to degrees, I take the angle, which has pi in it, by the way, and I multiply by 180 over pi. Why do I do this? Well, the pi's will cancel, and that's going to look really, really, really good for us here really soon. Okay, so we're going to practice those 2 skills. Here we go. How do I convert these to radians? Well, the rule is, if I want to go from degrees to radians, I multiply by pi over 180. Okay, so 120 times pi over 180. Now I see where that factoring stuff comes in. Factor label method. Ooh, degree on top, degree on bottom, they go away. What else goes into both of those? Well, 60 goes into this twice, and 60 goes into that 3 times, and I'm left with 2 pi over 3, done. Okay, how about negative 245? Well, I'm going to multiply by the same thing, pi over 180 degrees. Again, factor label method, we lose the degrees. What goes into both of those? Oh my. How about 5? 5 goes into 245. Let's see. 250 would be 49. And 180 would be 36. Oh, wait a minute. What goes into both of those? Nothing. So I get 49 pi over 36. That doesn't look right. I'll come back to that in a second. Let me double check my math there. 2, 4, 5, divide. Yeah. 180 divided by 5. Yeah. Yep, nothing goes into those. Someone must be right. 49 pi over 36. Yuck. Not pretty. How about this one? Oh, and it's negative. It was negative before. Don't forget the negative sign. How about 36? I multiply by pi, I divide by 180 degrees, I cancel the degrees, 36, that's pi over 5, because 180 divided by 36 is 5. I think you get the hang of that. Let's turn the page. Let's go the other way. What if I want to convert 2 degrees? Now I'm going to multiply by 180 over pi. I need the pi on the bottom so they go away. So I start with pi over 3 times 180 over pi. The pi's will cancel. That's the easy part. Now I have 180 divided by 3, which is 60 degrees. Okay. How about negative 3 pi over 4? I multiply by 180 degrees over pi. The pi's cancel. 180 divided by 4 is what? 45. And 45 times 3 is what? Negative 135 degrees. Let's do 5 pi over 6. I multiply by 180 degrees over pi. The pi's cancel. 6 goes into 180 30 times. 30 times 5 is 150 degrees. Not so terrible, is it? Not so terrible. We're almost done, I promise you. Okay, we did that a minute ago. Okay, the very last thing we have to do is we have to look at radian measure and arc length. This is a really simple formula which says if I am in radian measure, the arc length is the radius times theta, the angle. The radius times the angle. So if I were to tell you the radius in this case is 8, the arc length over here on this side, I'll make it red, this one, okay, the red arc length would be 8 times 3 pi over 4, well that's kind of handy, or 6 pi. Done. If I want to find the arc length over here, I'm going to do both of these by the way. This one is green and this one is red. And I'm going to tell you that my radius this time is 6. So to do the green one, I have to figure out what the angle measure is. Well, now wait a minute, let's think about this. 2 pi all the way around the circle, right? And I take away 7 pi over 4. Well, 2 pi is 8 over 4. So this would be minus 7 pi over 4 would be pi over 4. So this angle measure is pi over 4. So to do the green one, I would take pi over 4 times 6, and I would do a little bit of reducing here, and I get 3 pi over 2. The red one, I would take 7 pi over 4 times 6, again do a little reducing, and I would get 21 pi over 2. Again, not difficult, just a little bit of math. Okay, well, it's a little bit of a long lesson, but you can watch it as many times as you need. I hope that helps, and I'm here to answer questions if you have any.